Picture this. You're sitting at home, minding your own business, watching your favorite show on Netflix, and the power goes out. Or what if you're the manager of a grocery store, and the power goes out for long enough that your emergency generator fails and all your produce and frozen goods go bad? Or what if you're a major tech company, and the power fails while you're rebooting security programs, and then millions of customers' data becomes more vulnerable to attack? Or there's a power failure that makes all the traffic lights go out? Or you're in the hospital, and the power goes out. My point here is that not all cyber attacks come in the form of an irritating pop-up virus on your laptop. Some cyber attacks can target what's called critical infrastructure, things like the power grid, gas pipelines, and communication networks, which are all obviously essential to the functioning of our society and our economy. And the lack of these can really bring a nation to a standstill. So that critical infrastructure, it's important that we protect it from cyber attacks, right? But how do we do that? It's a whole tangled web of physical components like all the transformers and dams and windmills and power plants, plus the digital side, like all the software stuff that controls the way the power grid works. Enter Skyfall. Yeah, like the James Bond movie.
It was one of the first movies that I saw that was really touching on the theme of the cyber physical attacks and how they can really cause real world effects. So there was a gas pipeline explosion that was caused by a cyber attack, and a lot of other kind of incidents in the movie. I'm not going to give any spoilers right now, but that's kind of what inspired me, and I remember being very excited about that movie because it really kind of hit close to the work that I was doing at the time.
Okay, it sounds awesome, and it obviously does something really important, but what is it exactly? And how does it work?
Behind me, you can see common equipment that one would find in a typical transmission substation in a power grid. These devices enable us to see how these cyber attacks would actually behave and then replicate that behavior in modeling and simulation. To do this at larger scale, we actually need much more computing power. So basically, modeling one substation is not a big deal, but modeling the whole California network of both power flow and communications that are enabling that power flow actually requires high performance computing capability. And here at Lawrence Livermore, we're able to connect our physical testbed with our modeling and simulation capability, and then use high performance computing to see how these effects would propagate at scale.
Awesome. Okay, so Skyfall is what we would call a cyber physical test bed. It's like a laboratory where instead of petri dishes, we have a test power station. But I still don't really understand how something like this, that's all physical wires and electricity, can be hacked by someone who's messing with computer code.
So the way that systems like power grids work is that they have these control devices that need to be able to communicate with each other to ensure that the processes that are going on in the power grid are functioning the way they're supposed to be. So a lot of the times, modeling just the power flow of a system is not enough. We really need to model both the network and the power flow. That's one of our unique capabilities here we have at Lawrence Livermore is ability to do coupled simulations. So we can simultaneously run both the network and the power flow model and see how they interact with each other. And that really enables us to see how cyber attacks can affect the system from the moment a malicious packet enters the network, propagates through the network, affects the devices on that side, and then starts affecting the devices on the power flow. That enables us really to see end-to-end cyber attacks from the network to the physical real-world impacts.
So we've mentioned that Skyfall isn't just the physical side of things, it's also the code side. It requires flexing our high-performance computing muscles. Modeling and simulation in these areas is one way that we can use some of the fastest and most powerful supercomputers in the world, which we happen to have here on site. And this is just the beginning. Skyfall is currently configured to help us ask questions about the power grid, but it could also be used to help us better understand the vulnerabilities of other pieces of critical infrastructure, like gas pipelines, or networks of autonomous vehicles, or smart home networks. But one lingering question still lurks in my mind. To be able to ask all these questions and run all these tests, we have to have bad stuff to introduce into the system to see what happens as part of the experiment, right? Like access to the malware that causes the destruction? That seems a little risky.
Another part of Skyfall is MCAC, which stands for Malicious Code Analysis Center. And that's basically the part of Skyfall that really looks at malware. And we have these separate machines that are only used to store malicious software, and we analyze it, understand how it behaves. That's how we're able to take that behavior and then replicate it in our testbed or in our modeling and simulation environment.
Whew, okay. It's quarantined. That makes me feel better. While Lawrence Livermore may not be the top secret government DOE lab that Stranger Things would make you think, we do have bond-worthy projects, making the world a safer place and helping us understand some of the most pressing threats we face today. We're putting out new episodes of Inside the Lab every month, so subscribe to this channel for more videos like this, and let us know what topics you'd like us to cover in the comments below. To tide you over until the next one comes out, check out these videos here. These ones. These. You can click them. Thanks for watching. It's Livermore. Lawrence Livermore.